I'm at our booth.
What? The Nordic Semiconductor booth?
Yes.
Should we see what's on there?
Yeah, we can have a look.
Let's go and have a look.
Good. Okay, I think maybe we just do the whole tour. Have a look at everything.
So first of all, you're at Nordic Semiconductor. If I'm a design engineer, the reason why we do the videos is because not everybody can come to the show.
Exactly.
So we always say, we show you the things that you wouldn't see. So what am I missing generally, before we go through the demos? What's the reason that somebody, if they come to this show, should come to your booth and say, what have you got going on at Nordic Semiconductor?
So the main reason, you can have a look at most of the demos yourself. The main reason to actually come to the booth is to talk to the engineers that sometimes build our demos, but also the engineers that, if you have a problem, that are the same persons, the same people that help you fix your design, that help you get going if you run into any problems. Because that's actually our booth staff. So we have our actual engineers that are in Dev Zone. If you have a Dev Zone ticket, these are the people that you will be talking to. It's the same people that are here on the trade show.
So in the same way that when you meet somebody on Teams or you meet somebody on site, you're having real life engineering problems, it's the same experience that you get on the booth.
Yes. We hide the salespeople in the meeting rooms and there's mostly engineers on the booth.
Very good. Right, shall we have a look at your first demo?
Yes. First demo. This is actually a demo that Marty built herself. But we'll just have a look from the side. At the moment, what we can see is one of our engineers showing one of the customers something, but usually we're showing low power Wi-Fi. So we're showing the difference between target wake time and legacy power saving mode. Just the way how you can use Wi-Fi in a very, very low power consumption way, which Wi-Fi really isn't made for.
Yeah.
But with Wi-Fi 6 and with our chipset, you can actually get close to Bluetooth power consumption on Wi-Fi.
Right.
The second demo that we have there is actually a Linux host processor and then our Wi-Fi chip next to it. Maybe we can have a little zoom in on that demo.
There we can go now. So if I'm understanding what you're saying here, you're bringing very low power Bluetooth. So what kind of applications would you expect this to be embedded into?
So let's say you have a normal smart home application, right? But you wanted to run on Wi-Fi, but you also wanted to run on a battery. Let's say you have a sensor, for example. Usually, if you use Wi-Fi for that instead of Bluetooth, you have like an eighth of the battery lifetime. If you're implementing it properly, using the proper feature, you can get more than half of the battery lifetime than you would get just using Bluetooth. But you're still benefiting of it running over Wi-Fi because everybody has Wi-Fi set up at home, right? So it also works when you're not there. That's an example. Or things like industrial automation, anything where you want to run Wi-Fi off a battery.
Right. So Wi-Fi for battery, and this is showing that in low power. Excellent.
Yes. Here we actually see it. This is it running on very low power at the moment. We have an average current at the moment of about 500 microamps while being connected to Wi-Fi. If I switch to the legacy power saving mode, which is what usual Wi-Fi devices run on, then we see
the bump.
This new wave coming in here, and our average power consumption is gonna go up to about 10 milliamps. So there's a really big difference and power saving features that you can.
So you can actively see the legacy system using up more power.
Yes.
And then flick it back.
Because the legacy system, the time you sleep is being dictated by the router. So as an anti-device manufacturer, you have no way of deciding how long your device sleeps. If you're using something like target wake time, you can say, and that's what we're doing here, I want to connect every 10 seconds. But you're still saying, you're still staying connected, and you don't have to go through this recommissioning method. So it's not like you're completely off. You stay connected and you can still send and receive data. So it's a very nice way to do this.
So that's programmed to go in and talk to the server every 10 seconds,
yes.
Which is also a way that it's saving power.
Yeah, and you can decide this interval by yourself. It can be 1 second, it can be 10 seconds, and it can be up to a day if you want to.
You predetermine and pre-program when it does that.
Yes.
Excellent. Good. Right. Let's move on to the next one.
Good. This one's free. This one's also very interesting. This one's one of the interesting demos. You see, I actually brought a measuring tape.
Oh, goodness me. An interactive tool for a video.
Yes.
Right. Good.
Because what we're showing here is a Bluetooth feature that's called channel sounding. What we're basically doing is we are using phase shift, so like differences in frequency, to measure distance between two normal Bluetooth devices. So normal Bluetooth connection, but we use that to measure the distance between two kits.
Right. And so what would these two kits be doing in the real life?
Very easy one that everybody can think of is wireless key fobs, for example, for a car.
Yep.
It can be something like tracking assets at home. It can be tracking people. Let's say you want to find your key at home.
Yep.
And your key has a Bluetooth chip on it. You can actually figure out not just am I somewhere in range of it, but you can see, okay, is it getting hotter? Am I getting closer to my key when I go into this room? So you can actually have an information that, okay, like here I'm 2 meters away from my key, here I'm 1 meter away, so it's likely to be in this area.
Right. Right.
So like asset tracking in-house, it can be access control. So like if somebody walks
when you
close
get
to their
close
door,
to it, it automatically lets you in.
automatically unlocks. But it's a lot more accurate than, for example, RSSI-based methods.
Right, right. So the real what you're actually demoing here is these two things talking to each other over Wi-Fi.
Over Bluetooth.
Sorry, over Bluetooth, and they talk to each other. And what was within 2 meters that they'd recognise each other?
No,
and then...
they recognize each other all the way. Like when they're more than half a meter away from one another, then you can actually relatively accurately measure the distance in between them.
Right.
While doing all the normal Bluetooth thing that you would also do.
Right.
Usually you would expect one of these devices to be a phone.
Right, yes.
And then the other device is something that you want to find or that you want to know the distance to.
Yeah, yeah. So anything with a phone, anything you want to connect it to, whether it be you've got this key fob example here, I mean, there are just millions of industrial examples of asset tracking, things moving around that you'd want to recognise when it comes into the vicinity.
Yes.
Excellent. Good.
Let me demo it once for you.
Please.
If I just get this to 2 meters, we'll see on the screen the distance estimate at the moment is 2.1. So it's relatively accurate.
So, Finn, tell us about what's going on with this demo.
Yes. So this is a demo. We are demoing Meta, which is the smart home standard to unify them all, basically.
Yep.
We're actually showing two different things. So one of the really nice things that we're showing here is what we call thread in mobile. You might know that some of the newer phones here, for example, you have an iPhone, actually already have an 802.15.4 radio, which is the same radio for Thread and Zigbee. And it supports a really nice use case, which is if you want to have a one-to-one connection via Thread, because usually you need a border router, something like we have here for our other Meta demo. But what you can do here is you can have a one-to-one connection, in this case between the window blinds and this phone.
Yep.
So if I take these window blinds and I open them all the way, they should be opening all the way.
Don't you just love it when a demo works? Hey, don't you just like being interactive?
Yes,
and real time?
We can get some B-roll of the window blinds opening. The other thing that we're showing is we also have one of our development kits connected here. I think now it's going soon. We have one of our development kits here that acts as a door lock, and you can also see it showing up here as a door lock.
So if we, the whole point about this demo, let's get away from the fact that that didn't work. The whole point of this demo is you're over the network. This is communicating to give the mobile phone the ability to talk over platforms to whatever the devices there are that is connected via this hub using your technology.
Yeah. So the main thing is this solves one of the really big problems Thread has as a technology. Because Thread is a mesh network and it usually needs a border router to manage all the connections. But if you want to buy your very first smart home item, like a window blinds or a lock, you want that one to work immediately without having to buy a border router. And now you can use your phone to have a one-to-one connection via Thread to have that working.
So what this is offering is this very easy interconnectability with the phone and any devices that you've got in the smart home, so you don't have a big issue with connecting things up and then dealing and talking to your smartphone.
Yes.
That's essentially what this demo is showing, and the technology that is within this board.
Exactly.
Excellent. Good. Let's go on to the next one.
Good.
So we continue this booth tour with Finn. What a fine booth tour coordinator he is. Multi-connectivity and locating. What do you got going on here, Finn?
So if you've seen us on a previous trade show, you've probably seen this setup in general once before. What we're showing here is this is a web application where we have locations. We have several devices all over the world connected. They're talking to our cloud. So we're showing here connectivity via cell. We're showing locationing, we're showing fuel gauging on the kits, but the main showcase that we want to show here is these kits now actually, the same hardware supports NTN, so they support non-terrestrial networks. So if we wouldn't have a roof over our head, we could actually, and we can, talk to satellites that are geolocationary or low orbit satellites with actually the normal PCB antenna.
We've gone off planet.
Yes, we've gone off planet, but not just like GPS one way. We can actually talk back, ping the satellites, send data back and forth.
Yeah. So would this be, I'm just trying to understand, would this be like a network with several devices out in the field? So what's the real life application for this?
The best real life application, I think, is something like asset tracking. So if you have moving assets or you have assets that are way out, maybe even in a location that's so remote you don't even have cell phone connectivity. Then you can use satellites to still get your data out.
Right. So very remote places, very unusual places where you can still offer the ability to know where they are, going off planet, connected to satellites, and then being able to talk to them and find out where they are.
Yes. One of the things that we're showing, you see here different stickers on the kits. We have different suppliers for eMMCs, so for electronic SIM cards, and also for soft SIM. So the same chipset also supports SIM completely in software.
Right.
We work together with different manufacturers.
So the point being there, you're not tied to any particular service provider.
Yes.
Your hardware understands and will integrate with it, whatever you are tracking via this box. You aren't tied to a certain service provider or a certain type of technology.
Exactly.
You have the adaptability to be agnostic.
Yes. And also you can choose in between having a SIM in hardware, like an actual SIM card, or just having the SIM completely in software, which is a pretty nice thing to do.
Yeah. So tell us all about low power cellular.
Exactly. So the exact same chipset that we've seen on the other side doing all the locationing things and talking to the cloud and talking to satellites. Here we're showing this same chip talking to cell masts, like talking to a cellular network. What we're showing here is basically that you should not trust things that are in a data sheet. You should check everything for yourself. Because we've set up one of our kits, and if I remember what I need to click, if I press this button, what I'm going to do is I'm sending a UDP package. And you see, it took about a second to send a UDP package and go back to sleep. When I'm sleeping, I'm at 2 microamps, which is basically nothing. That's not much more than your battery discharges itself without anything.
Just to exist.
Yeah, just to exist.
Yeah.
But this is using a feature that we've integrated, which is a fast release. Because usually what happens when you want to talk to a cell phone mast is you have to connect to it. And when you want to send data, it forces you to stay connected for a certain amount of time before you can disconnect. But when you're making it so that it's releasing you faster, then you can save an incredible amount of time. So if I then disable RAI, which is this fast release feature that I told you about, and I send the same message again, what we should see is a lot longer time. And here we see where we stay connected before we eventually drop off. And this whole thing consumes about an order of magnitude more power because the cell tower forces us to stay connected.
Yeah.
And this is one of those features that you don't see if you just look at what's the power consumption in the data sheet, because you need to actually test the application, and that's when you see how much power you can actually save when you use the right chipset, and when you work with a manufacturer that actually has years of experience in this field.
Yeah. So in that particular case with the cell towers tend to dictate to the device how, because that's their job.
Yeah.
Cell towers' job is to constantly look and constantly communicate.
Yes.
So what the whole point of what you've said is that actually what you've got to do is take control of that situation, because otherwise the cell tower will happily communicate with you. It's connected, it doesn't care how much power it uses. It will quite happily connect all the time.
Yeah.
And you've got to say, hang on, I only want to communicate at a certain amount of time because I need to be losing as less power as possible in my communication. So in all the demos that we've done, that is a recurring theme from everything from Nordic Semiconductor, isn't it? This absolutely ability to know when you actually want to use power, when you actually want to communicate, and be very, very efficient in the way that you use it.
Yes.
That's the thing that comes through this booth tour, is a constant of understanding the absolute imperative of power.
Yes. So,
and how do we drive that down and down and down and down and down? And it seems to me that from Nordic Semiconductor, we talked about other things, but from Nordic Semiconductor's point of view, one of the absolute ways and clever ways of doing that is being very clever in understanding when you want the device to be communicating and when you don't want the device to be communicating.
Yes. And to be able to wake up incredibly fast, go to sleep incredibly fast.
Yeah. Yeah.
And one of the main features that we've seen at Wi-Fi, but that we can also see here. So one of the things that you also really want to do is oftentimes when you do the initial first connection, and this is also the case for cell phone towers, when you want to do your first connection, that takes up a lot of power. So what you want to do is you want to stay connected. You want to have a slot in which you can talk without actually disconnecting. And this is also what we do here, because it consumes 2 microamps at the moment, but we are still connected to the cell phone tower, because we don't need to establish the connection again. If I go to actual modem off mode, which I can also do, then I go down to 1.9. So I basically save nothing. So we have a way of staying connected by using about 0.1 milliamp, about using 0.1 microamp more than being completely off. But if I want to reconnect, then we actually use quite a lot of power for this establishing of the connection. So the staying connected, not dropping the connection, saves an incredible amount of power. And here we see how long this takes. This is like more than 10 seconds to establish the initial connection. And it was the same thing at the Wi-Fi booth, because if we talk every 10 seconds with target wake time, right, then we stay connected, but we use very little power, but we don't have to establish the connection again.
So you said something at the beginning, which was take control of your application.
Yes.
That's also been a theme, because if we go back to the things that you said about when the device turns itself on and when it communicates, you said it could be 10 seconds, it could be a minute, it could be, I can't remember what you said, but the point is always understand and take control of when the device is turning itself on and when it's turning off, because we give you the flexibility to do that.
Exactly.
And we know that that's the most accurate way and the best way of saving power.
Yeah.
Very good.
You can say it like that.
Very good.
So I've told you this is my favorite, or this is our main demo. I want to explain why. Because this chip that we have here, the NRF52 series, that chip is basically in half of the Bluetooth Low Energy devices. Point.
Yes.
It is in half of the Bluetooth Low Energy devices. This is the most used Bluetooth chip in the world by far. This is its successor. It basically does all the same things. It does it twice as fast with about half the power consumption.
Right.
And this is exactly what we're showing here. So here I have one device of the 54L series and one device of the 52 series. And we are showing them doing the exact same thing. So the first thing, and what we're looking at the moment, is a normal scenario, which is Bluetooth advertising. Here we see a normal advertising interval. I'm using 270 microamps compared to 170 microamps.
So these are doing the same job.
Microamps.
This is doing the same job, and this is showing the less power it's using, and that's just running, which would still view that as being low power.
Yeah, that's.
We'd still absolutely view that as being low power. 50% of all devices have that as their low power point.
Yes. We can also change, for example, the interval. We've talked about saving power. A way to save power is by having the interval where you're sleeping a bit longer or where you're not sending a bit longer. So we go a lot lower in power consumption here.
Yep.
But even still, in this use case, we're still way lower on the 54 series than the 52 series. If we want to do the main thing that you want to do with Bluetooth, which is have a connection, we can also do that. So if I press this button, what we're gonna do is each of these kits are gonna establish a Bluetooth connection
Yep.
to one kit that we've hidden in this little box here.
Yep.
And even in the connection mode, you see we are not.
So these are these two separate chips doing their job. That's what they are. They're low power Bluetooth. Owns 50% of the market, and then you're just showing here. This is the NR54, and it's almost half. It's not quite half, but it's
We can get to half if we go to a different use case.
Right.
Because this was a Bluetooth LE connection, but if I press this button, we go to MCU efficiency and performance. So what we're actually doing here is we're doing very heavy calculations. So if I do this, we're gonna see two things at once. You see, first of all, the time that we take to do the same calculation is about half, which
Right.
means we go to sleep twice as fast. So
Yep.
even
We're
if-
back to that sleep, going to sleep, being on when you need to be on, doing what you want to do when you need to do it thing.
Yes. So even if they were consuming the same power, this would now consume half because it's twice as fast.
Yeah.
But it also consumes less power overall, which means we have about a third of the power consumption when we go to heavy processing tasks.
Right. And where do you see then? Where do you see that need? Where do you need that extra power, that extra horsepower for compute?
So this is the actual interesting thing. In most cases, you don't need to have the power to process a lot. But if you have that power, you do the processing quicker, which means again you go to sleep faster.
Yeah.
So you very rarely max out your processing, but you want to have a lot of processing power so that you can go to sleep fast.
Right. So it's processing power to just get to sleep quicker.
Yes, exactly.
Basically, that's what's going on
If you
there.
run home faster, you can go to bed faster.
Absolutely. Very good. Very good. Right. One more.
One more. Okay.
Let's look at the last demo on here, which I believe you're going to do in French because it's Bluetooth audio.
Well, actually, you're allowed to have your own opinions. I will say any audio. But what we are showing is a subset of Bluetooth LE audio, which is just the broadcasting features.
Yep.
Those are called Auracast, so they have their own brand name. The cool thing here is it is now supported in normal phones. So what we can do, let me just try to get this in a way where the camera can actually see this. I have a normal headset here connected with normal Bluetooth settings. I connect the headset.
Yep.
That is this one, by the way.
Yep.
And you see this icon is a bit different than it usually is. It has this tiny A. We can zoom into this with the camera a bit later on. If I click here, it actually offers me different options. It says, listen to Auracast. By the way, this is the phone. We changed nothing. I just bought it, unpacked it. It supports this. And now it'll show two different broadcasters. It has the NR53 broadcaster and the NR53 alternative broadcaster. That's these two. So they are broadcasting audio. We could listen to this with 1,000 phones in the area. So unlimited device that it talks to. And it comes out here. Another special feature that I can also show is I have one. This is a mic. We call this a high priority broadcaster because what this does is if I press the button here in the middle, you see these two kits turning red.
So the whole point about this is one device talking to many, many, many devices.
But also a special feature which means you can tune into higher priority broadcasts. So whenever I press this, these two light up red, and then you would hear my voice instead of the music. we can also demo that. I'll just click this into your camera in a second, and
Yep.
then we'll show the
Right, very good.
everyone watching how this works. Now actually you should see these kids turning red. So you're actually hearing my voice through this development kit. If I stop pressing the button, you can go back to the nice non-copyrighted music. Now actually you should see these kids turning red. So you're actually hearing my voice through this development kit. If I stop pressing the button, you can go back to the nice non-copyrighted music.
We've just done our booth tour at Embedded World 2025, where we've been talking to Finn. Big thing that comes out of this booth tour is this whole concept of, we know Nordic Semi is all about low power. We know it's all about Wi-Fi. We know it's all about Bluetooth. The really clever thing that we keep hearing as a recurring thing is when the device turns itself on and when it communicates. And what you've been able to do is show how you can save even more power using their technology because of the clever things they do over and over again, refining, defining how you use power and how efficiently you use power.
That's it. You've put it well. We forgot Cellular and non-terrestrial networks. But other than that, that's it.